Hi guys. Right, so today we're going to learn about mean proportional. Before we start, it's important to know that mean proportional can also be referred to as geometric mean. So before we get into it, we need to understand what mean proportional is. So the definition of mean proportional or geometric mean is the mean proportional is the square root of the product of two numbers a and b when they are multiplied together. So we're going to start here. We're going to take a rectangle, for example. So this rectangle here is 36 centimeters squared. That's the area of it. So the length of this side here is 9 centimeters and the width of it is 4 centimeters. So we have a square which has the exact same area, 36 centimeters squared, but this square has a side 6 centimeters by 6 centimeters. So now we're going to take this rectangle, I'm going to bring it down here. So the first thing we're going to do to this rectangle is we're going to extend out this line here. And the reason why we're doing this is because distance from here to here is going to be transferred up onto this line. So how we're going to do that is we're going to put the pin of our compass here, where the pen is, and we're going to stretch our compass out to this point, and then we're going to swing an arc up to where it meets this line. So the next point in this process is going to be to find the center of this line. And essentially what we're doing is we're going to bisect this line. So by putting the pin of our compass here, striking an arc, the pin of our compass here, striking an arc, we're going to find the center of this line. So here we found the center of the line. So what we can do from this point is we can construct our semicircle or our curve. So by putting the pin of our compass here, swinging it all around so that it meets this point here. So our next step is to bring up this point here up to meet the curve. Where this hits the curve, bring out a dotted line. The distance from here to here is our mean proportional. So essentially what we can do is, like we said before, this was 36 centimeters squared. We could construct our square inside here too. So that's the distance of one length of the square. So we'll say from here to here. So if we just transfer that over here and transfer it over here, we could create a square inside here if we wanted. So we could construct a square in there. And basically that would mean that this square would also have an area of 36 centimeters squared. So now we're going to develop this point. What we're going to do now is we're going to bring this line from here to here, down here. So here's the start of it, and here's the end of one of the lengths of our rectangle, and here then is the 4 centimeters over here. So again, we're going to bisect this line. So by putting the pin of our compass here, strike an arc, put the pin of our compass here, strike an arc. This will help us find the center of our circle or arc. So then we construct our semicircle. Right, the next thing we're going to do is this point here, just like we did up here, we're going to bring it up to meet the semicircle. And what we can do here is we can actually create two triangles. We can create triangle A, which is here, and we can create triangle B, which is here. So looking at these triangles, we can see that they both have right angles here and here. But if we look a little bit harder, we can see there's actually a third right angle in this, and that is up here. And the reason for that is, whenever there's a triangle constructed within a semicircle like this, so along here and up here, where it meets the curve, there will always be a right angle. So just like here, look, over and down, you've got your right angle. So we can actually start to put in some more information on both these triangles. So here we know that this is 90 degrees. Then this over here must be 30 degrees, and this up here must be 60. And 60 plus 30 will give you 90, so that's a 90 degree angle, which means there's 60 degrees left over. Now we're going to label these points because we will need them later. So A, B, C, and D. So we start to look at the triangles and we see that they look very alike. And then we realize these triangles are what we call similar triangles. So the triangle A, B, D is similar to triangle B, C, D. And what that means is that we can see here that all the angles are the same, 30, 60 and 90. We've got a 60 here, we've got a 30 here, we've got a 90 here. But they're different lengths. That length is not the same as that length. So we're going to take these triangles out separately now. So here, I'm going to draw triangle A. So that's A, B, and D with angles 30 degrees, 90 degrees, and 60 degrees. And now we're going to take out triangle B. But before we do, what we're going to do is we're going to rotate triangle B 90 degrees anti-clockwise so that it has the same orientation as triangle A. So by doing that, that means now what we have is D, B, and C. Now we can go and fill in this information here. So this angle up here is 60 degrees, this angle is 30 degrees, and this is 90 degrees. So now that we've got it all drawn out, what we need to do now is prove it. So now we're going to do the proof. Because the triangles are similar, as we see, we can state that B, D over A, B is equal to B, C over B, D. And what we're going to do now is we're going to cross multiply. So it's B, D by B, D is equal to AB by BC. So BD multiplied by BD gives you BD squared is equal to AB by BC. So now I want to get this on its own. So BD is equal to the square root of AB by BC. So there we have just proved mean proportional. Before we finish up, if we just look back at the start, the mean proportional is the square root of the product of two numbers when they are multiplied together. So the mean proportion is the square root, which we have here, of the product of two numbers when they're multiplied together. So two numbers here multiplied together, square root. So therefore we have successfully proven the mean proportional. Thank you.